Okay, here's a question that in which they are asking to find two real numbers, really they're angle measurements, between negative 2 pi and 2 pi that determine each of the points of the circle. So let's start with point M. So when I look at point M, where is that? I know that this is my positive x-axis. Positive angles are going this way. Negative angles are going this way. And also if I go around once, that's 360 degrees. But in this section, we're looking at radians. And so really we should be thinking that that's 2 pi radians that whole way around. Or I guess you could call that 6.28, right? Because 2 times pi is 6.28. Anyway, they want us to know where M is. Well, M's not halfway, so it's got to be less than pi, right? And this one here is half of pi, so it's got to be bigger than half pi. Right there would be half of pi. This is 1 whole pi. This is 2 pi if you go all the way around. So it's got to be in between there somewhere. Now all of these ticks here, and the special ones that we use in the unit circles, that this one stands for 30, this goes up another 30, there's another 30, another 30, another 30, 30, etc. So these ones on the ends right there are 30 degrees. The one in the middle, of course, is halfway around. So if this is 90 degrees, that would be a 45 degree. But let's just focus on these ones. So how many of those are there? So there's 1, 2, 3, 4, 5. There's 6 of them in a half a pi. And so, or not a half pi, in 1 pi. So this would be 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi. Oh, that's the one we want, 4/6 pi. So M is actually 4/6 pi. Or if you simplify that, that would be 2/3 pi. And that's positive because I was going up this way. They say it can also go backwards. So if I go backwards, then it would be, I guess if the whole thing is 2 pi, I could say that the whole thing is 6/3 pi. So if I go to there, that would be, maybe a better way to think about it is in terms of thirds. So if there's 1/3 right there, there's 2/3 right there, 3/3, 4/3. And each time I'm jumping 60 degrees. So if I went backwards, that would actually be a negative 4/3 pi. And both of those would be, you would call those coterminal angles. Now, if you have a hard time thinking in pies, you can just think in degrees too. So 30, 60, 90, 120. So that's 120 degrees. If you want to know how far that is in pies, then just take and, whoops, instead of equals, I can go multiply by pi over 180. And then simplify. 60 goes into there twice, 60 goes into there 3 times. So there's my 2/3 pi, like I had there. And if I went backwards, it'd be 180 plus 60, or 240 degrees, and I could do the same thing, multiply it by pi over 180. 60 goes into there 4, 60 goes into there 3. Since I'm going backwards, that would be negative 4/3 pi. Okay, let's try this P1. P1 is on a 45 degree angle. Let me change colors. So P's on a 45, so if I'm going positive way, I can think 45, 90, 135, 180. 180 plus 45 would be 225 degrees. So I could write it like that. Or pi's or 45s are quarters. So you can see I can go 1, 2, 3, 4. So there's 1, 2, 3, 4 quarters in 1 pi. So this would be 1, 2, 3, 4, 5 quarters pi. And again, you can do the 225 times pi over 180. 45 goes into there 5 times, 45 goes in there 4 times. You're going to get the same thing. If you go backwards, it'd be 1, 2, 3. So it'd be negative 3/4 pi if you went backwards. Hopefully that helps you identifying some points there on the unit circle. Keep in mind that whether you're doing it in pi radians or normal or just regular radians or in degrees, they're all meaning the same thing. And if you work better in a degree world, feel free to work in a degree world, but then be able to convert that into radians whenever you want, or vice versa. I found that it's nice to be able to work with both worlds rather than just stuck in one.